This is still Chapter 8 on energy. This PowerPoint is called Work Energy Power. And we are in section 8.4, where we talk about potential energy. There's a review of the definition of work. The third line down has the equation, work equals force times distance. And then the next line says, work can be done by you as well as on you. And I have an example for that. Work can be done by you as well as on you. So if you're climbing a tree, if I'm standing on the ground and I start to climb a tree, it takes work to climb that tree. And I can go pretty high, but we all know what happens if you fall out of a tree. You hit the ground and it hurts. And the higher you go, the more it hurts. So when you're still in the tree, at the top of the tree, just like the person there with the red sweater, you haven't fallen out of the tree, but you have the potential to fall out of the tree. Do you know that word, potential? There's the definition. It means capable of being or becoming. So you have the potential to fall out of the tree. You are capable of becoming the person falling out of the tree. Does that make sense there? I got that just out of good old dictionary.com there. Capable of being or becoming. So if you're at the top of the tree, you have the potential to fall down and hurt yourself. And that requires work to get up the tree. Where did that work come from? Well, you're the one that did it. It takes work to climb the tree. How much work does it take? That's where we get into the physics of it. So that potential energy is there because gravity is pulling us down. So we call this gravitational potential energy. And 90% of the time in this chapter and in the unit, we're going to be talking about gravitational potential energy. So much so that a lot of the time we forget the word gravitational and just call it potential energy. And then if we talk about a different kind of potential energy, like chemical or something, we'll usually use the word chemical in there. But for now, gravitational potential energy is potential energy. And near the surface of the Earth, this is how it works. So I've got a green box in my little picture there, and I've lifted it up, and I've raised it a certain height. And that box has a mass. I just labeled it M for mass. So then I have the work equation. Work equals force times distance. And the force is in purple. And F equals ma. Do you remember that? So I just took force and turned it into m and a on the second line there. And distance, well, since I'm working against gravity, I just call it height to keep that idea of going up against gravity. And if, by the way, if you look at the notes for this, I do this in a lot more detail. So then I've got work equals mass times acceleration times height. Well, the acceleration, since we're on the Earth's surface, is always going to be g, which is 9.8 meters per second squared. And when you're doing the homework, you can round that up to 10. So then I just do that, and then I do that substitution. Work equals mgh, mass of the object, g for the acceleration due to Earth's gravity, and h, the height that you've climbed. So then I have a few examples. But I think I'll do the examples in a second video. So that's all we needed to get through the notes. Thank you.